Welcome everyone in summary session for course titled MA91 Production Technology Theory and Practice. First of all, we solve the problems from the assignment for week 12 and then we'll proceed for the summary session. Okay, so these are the problems for assignment for week 12. The first question: tool used for making a semicircular groove on a cylindrical job on a lathe is. So right hand tool, left hand tool is wrong, and the parting is tool used to cut off the part. Okay, used to cut off the part or simply job. Okay, so only form 2 this is the correct answer. Okay, to produce a semicircular groove or cylindrical job, form 2 is only the correct answer. Okay, knurling is made on a workpiece for a purpose of, you know what knurling actually means. Okay, this kind of thing we have, which is called as knurling. Okay, and what is the use of it? This knurling, you know, it is present on many things where we need to get to grip it. Okay, like screw micrometers, we saw this kind of arrangements. Okay, so what is the use of it? To actually have a better grip. You can see here the grip. If you place your thumb here or any finger here, you can see the grip that you will get here. Okay, to get a firm grip, it is used actually. So holding lubricant, there is no use of lubricant here. You can know there is no use of lubricant in that outer dial of micrometer. Okay, knurling is mostly used to for better grip only. Okay, to have a better grip, so your fingers will rest there accurately. Yes, so holding lubricant better look, it is not having a better look. It is actually having a problematic look. You can see there is a like diamond shape like scratches are there. You can see this kind of diamond arrangement. So it is not for better look, okay, you know. And reducing the weight is again not because you remove the material here. Actually, it is not for reducing the weight. It is for just for it is actually having some kind of advantage, some kind of application. That's why you are using it. Just a better look and reducing the weight, holding lubricant is not here as per the actual application. Okay, so it is not done for that. Okay, so only so knurling is specifically only done on for better gripping. Okay, on any of the things for if you need a better grip, then you need to prefer knurling. Okay, you can see in many things there are this kind of patterns are made for better grip only. Okay, so knurling is only preferred for better grip. Is standard answer. Okay, this kind of shape you have in knurling. Okay, this is the knurling. This is how knurling is done, and for better grip is the correct answer. Okay, so the combination of speed V, speed F, and a depth of cut is used in roughing operation. So high speed and D. Okay, so it is not correct answer. High V, low speed and depth. It is actually used for we are using high speed, low speed and depth of cut. Means it is actually a finishing operation. Okay, it is a finishing operation. And low speed, high speed and depth of cut, which is actually roughing operation. Okay, what we can expect here? Here we can expect more material removal. You know this fact. Here you can expect more material removal. Okay, material removal is more. Hence, rough or rough finish, you can say. Rough or poor finish. Okay, so low speed, high speed, and depth of cut is only correct answer. You can just see you are using high speed and depth of cut means material removal is high. As material removal is high, yes, rough or poor finish. Okay, rough or poor finish is about to be there. And with high speed, low speed, and depth of cut, it is finishing fast because here the material removal is less. You can see material removal is less. Hence, good finish. Okay. So it is finishing operation. So for roughing operation, you have to use a low speed but high speed and depth of cut to get more material removed. And low if this high, everything high means speed also high, speed also high, depth also high. It is actually not roughing. It will create something problematic. Okay, this is highly unconditional. Okay, high. This is not actually correct way. Okay. And low feed and depth of cut is actually again low feed. It unnecessarily increase your machining time. Finishing pass you require actually high speed. Finishing pass. Okay, see, this is actually finishing pass. So for finishing pass, you require high speed, and for roughing pass, you require low speed. So low VF is again on actually not accurate. Okay. These two are actually not accurate. Everything high. Okay, so only high V and low F, and you to consider only these two options. And again, this high V, low F and D is for finishing, and this consider is for roughing pass. Okay, that is how we can get the answer. Fourth question. In a turning operation of cylindrical jaw, after one pass, the diameter is reduced by. Okay, so you know how we do the turning. Okay, so this is a turning, and this is your tool. So consider this is as your tool. This is as your tool. What you are doing in turning operation of cylindrical jaw, after one pass, the diameter is reduced by the value of depth of. This is your depth of cut. Okay, so this is your D. Okay, this is your D. Right now, what you are doing, you are using on lathe. Okay, so this will be your chuck. This everything you have to consider. Okay, so this will be your chuck, this is your chuck, and this is rotating. Shaft is rotating, a tool is here, so this part will come there. Okay, so it is rotating, so this part will come at that part after rotation. Okay, after one rotation, so this much amount you are cutting here, and this much only because it is rotating, so both from both sides it will be cut. So the value of the diameter reduced will be, you can see this is your diameter. Okay, this is your diameter, capital D. This is your depth of cut. Okay, depth of cut. Okay, and this is your D. So the value of the depth of cut, so diameter is reduced by value of the depth of cut is C. There is two depth of cuts. So value of depth of cut is wrong. Double depth of cut is correct answer. You can see I explained here completely. Okay, how it actually happens. The value of the feed is wrong. Double feed is different and depth of cut is different. No, feed is given in this direction. So actually you are considering the diameter direction. So this is not diameter direction. This is the length direction. You see. So feed is completely wrong answer. Only double the depth of cut value is only correct answer. Okay. I showed you here, okay, completely how this actually happens. Fifth question. In horizontal milling machine, the milling cutter is mounted on and adapter is wrong answer. Correct check is wrong answer. Okay. So horizontal milling machine we are considering. Okay. So quill is not answer. No, it is actually theory part. So arbor is also correct answer. You can show in that machine. Okay. Milling machine you can see in those videos. Okay. In the class notes. Okay. Even you can see actually it is arbor. It is standard actually. So you can see in the notes also standard. Okay. You can see in notes also. So arbor is only correct answer for horizontal milling machine. This quill, collect chuck, quill adapter is wrong answer. So arbor is only correct answer. Okay, so you can see the notes. It is standard answer for horizontal milling machines. Sixth question: the mechanism that can reduce the RPM of the driven shaft with respect to the driving shaft up to 40 times. Okay. Yeah, so a driven shaft with respect to reduce driven shaft can reduce the driven shaft with respect to the driving shaft up to 40 times. Okay, so your driving shaft can be reduced to 40 up to 40 times. So where you can get this kind of gear ratio. Okay, so this is like your input is 40 and you are getting just one rotation. Okay, so like this. So where you can see this kind of arrangement. I told you this is only gear with highest gear ratio. Okay, so this is only specified with this 40 as to 1 is specified with one number of gear only. The rack and pinion, mechanism and belt drive, it can be give you this much amount of gear ratio. Okay, so for reducing that RPM, you need proper gear ratio. What can provide this kind of gear ratio is worm only. And in my assignment also I told you if you go through lectures also you can see, and in assignment I covered this all kind of part. Okay, so 14 is to 1, which gear drive will give you this amount of reduction is only worm and worm wheel. Okay, so only this is the correct answer. So in taper shank drill, the torque is transmitted through Spring noted wall grew is wrong, dog and dog is not there, collector is not there. You know, in taper shack, what is actually happening? Most type taper, fiction is only correct answer. Okay, so you know the theory, it is only fiction is correct answer. Because it is the friction only by taper, that is creating the taper part. So this taper part is used for creating the friction. Okay, so the internal shape of the drill sleeve is okay. I told you already. You can see here the taper shape drills. Okay, so these taper tracks are actually using the friction to transmit the torque. But how they are actually transmitting torque means their internal sleeves are having most type taper. Okay, I told you in this part. Okay, this answer most type taper. Okay, this taper part, tapered shank drills. Okay, this taper part. So we actually transmit the motion using friction, and these things are only made on the drill sleeves also to transfer it. Okay, so cylindrical or the shape, the most type taper is only the correct answer because this taper by using friction actually transmit the motion. Okay, so this is the questions are actually connected to each other by using this actually by using the taper part. Okay, this taper is only correct here. So this most taper type is correct answer. Square, cross section, combination of cylindrical square type is again wrong. So they are actually asking for a shape. So here they are actually asking for how the mechanism, how it is actually transmitting, and there they are asking the shape. So here itself they are showing the taper part. So it is only taper part is only correct answer, and it is actually standard answer. Okay, it is widely used and it is standard answer. Okay, it is mostly used. Okay, so most type taper is the only correct answer for internal drill shoes. Okay, so basic purpose of reaming is to when we are doing reaming after drilling process. Okay, when you do the reaming process after drilling process, you know this part. Okay, so after drilling, due to the vibrations, there is actually you have a poor surface finish and diameter is also big. Okay, poor surface finish and diameter is also not correct. You know this part. Okay, so this drilling actually having some kind of problem. So to get rid of those problems, so they have some kind of problem. So to get rid of these problems, what we do? You introduce the reaming process. Okay. So to that tackle these problems only, you need to do a reaming process. So basic purpose is to vibration force especially diameter is not correct. So pure surface finish you can see here. So increase hole diameter after drilling, increase the hole. It is not. It is not correct means it is not actually basic purpose to increase the hole after diameter. So it is actually to make correct, not to increase. Reaming is not to increase actually. It is used to make it correct. Okay. So increase the whole length is again wrong answer. Straightening the whole diameter along its length. Straightening the diameter. Okay, so it is not a concept. Okay, so these conditions are now straighten the whole diameter along its length is wrong. We are not using ribbon to straighten it. Okay, it is already straight. So straightening is not is completely wrong. Okay here, and increase the whole depth. Okay, increase the whole depth is not instead of ribbon. Mostly you don't need that part over here. Okay, increase the whole diameter after drilling. So increasing the whole diameter after drilling. So I told you it is not used to increase the diameter. It is used to make it correct. Okay, so it is not to increase the diameter. Actually, make correct diameter. Okay, because of these vibrations and it is actually drilling having lot of vibrations. To reduce that vibration, we need to go with okay, so that vibration actually creates the pore surface formation incorrect holes. So to correct the hole, we are using reaming process. So these all options are wrong here. Only this, as I can show you the surface finishing pore. So only this option is correct. So only this will be your correct answer. Okay, I explained everything. In the assignment also I explain you right now here also I explain you everything. Okay. So the number of pits in remote is always given for increasing accuracy. Okay, increasing accuracy of remote is not again. There is no concept of number of pits here. Okay, it is given in the notes. Okay, it is given in the notes. So balancing the force, it is correct because the material remote is rate is low here. So balancing is again important because why you are just finishing. It is just a finishing process. Okay, so why you are using reaming? The previous question you can show to improve the surface finishes, the material removal is low. It is there. Okay, so material removal is low. So as material removal is low, so balancing is important. Okay, so balancing the force is important because of the material removal is actually less. So due to which the balancing force is important here. Okay, balancing it is actually important. So it must be even. So balancing that cutting force is important here because otherwise it will break. Your tool will break due to your unbalanced forces. Okay, so as your material removal is low. Okay, your material removal is actually low due to which the balance of the force is required. And increase the material removal rate is wrong because it is already a finishing pass. So increasing the material removal is completely wrong answer. Ease of fabrication of the reverse is not. It is not. We are not using ease of fabrication is actually a process. Ease of process to it is actually used to get a specific part, not to ease the fabrication of the reverse. Okay, it is actually used to make the part proper. It is only one concept. And the accurate measurement of diameter of the reamer. Accurate measurement of diameter of the reamer. What actually they are meaning here means it is actually if you go through notes you can get this answer. So this is both are correct. So ease of fabrication is wrong. It is not good for ease of fabrication with gears. You can do that. Increase accuracy is wrong. Material removal, increase material removal. Everything these parts are wrong. Balancing the force, as I told you, material removal is low, so balancing the force is required. Accurate measurement of the diameter of the removal is because it is finishing. I told you it is finishing pass, so your diameter must be correct. And here also I told you, due to which the diameter is not correct. Okay, so to make diameter correct, we need to go with the reverse, and to get correct diameter, we have to have an accurate measurement. Okay, so this is again an important concept. So for accurate diameter, we need accurate measurement. Okay, accurate measurement we need is needs to we know use vernier caliper. So in that cases those both of your cutters will be this like will be same plane. Okay, so if you have even number, so it can be your vernier caliper can be sit here comfortably. You are the jaws of your vernier caliper. Okay, so jaws of your vernier caliper, you have to see your jaw. So jaw of vernier caliper. That jaws of your vernier caliper will be sit here comfortably. Okay, means it can be sit here. It can sit here correctly if they have even number of them. Okay, so for accurate measurement, as you are using jaws of vernier caliper, you need even number of plates. Okay, so it can fit comfortably. Okay, so it can fit comfortably. Okay, so accurate measurement of the diameter. And so how how why because why the fit comfortable is important because this is actually finishing pass, and in finishing pass we require accurate diameter. So accurate measurement is required, and due to for that accurate measurement you are using vernier caliper again, and so that your vernier caliper will correctly mounted or correctly placed on the exact diameter. To get accurate exact diameters you need even number of pins. Okay, so for getting your correct accurate measurement and balancing force is only a correct answer. Okay, so ease of fabrication it is not for concern. Ease of material removal again is completely wrong, and ease of accuracy, increase accuracy of reading, that is not a concept of number of pieces. Okay, so balancing the force and accurate measurement, not a accuracy, accurate measurement is because to get the jaws of one caliper comfortably fit, correctly fit to get accurate measurement. Okay, so this is only the correct answer. Okay, so ease of fabrication is not here, but removal is increase is not here because it is already one. Accuracy is again not concepts. Okay, so what is your correct answer? 2 and 5. Okay, so D is only a correct option. Okay, so you can get here D is your correct option. It is actually 2 and 5 it is showing here. So this is the correct answer. Okay, so here we are actually completed the assignment for week number 12. So we are moving forward for the summary section so you can get insight of the subject and you can prepare well for your examination. Okay, so what things it is important and what things you should cover. So this part will cover here in our summary session. Okay, so this summary session is important for your examination part. Okay. So the course summary is that what they have covered, material and their properties. You know that material and their properties means what you should consider that the materials and the properties of the materials. Okay, and the properties of material, how to check it. Okay, so what are the materials that can be used like steel and carbon, the percentage. This is steel and different materials and the properties of that material. Okay, how to measure that properties, the defects part, and you know this part. Okay, so steel is there, other different materials are depending upon application, their alloying, their defect, and properties also their stress, their strength and the rigidity and the other properties like ductility. So this part you should go properly. Okay, this part you must go, and most importantly the materials that can be used and the properties that the material should possess, or the way you can check the properties here is important option here. Okay, so introduction to machining processes. So what are the machining processes you have, and most typically cutting process here. So introduction to different type of machining process are actually mentioned here. The types of chip, tool nomenclature, tool angles. Okay, so types of chip, what kind of tool considers this continuous tool nomenclature. So OSA, okay, so ASA, ORS. Okay, ASA, ORS actually. So ORS is this kind of part you know. So ASA, ORS you know, and this kind of tool nomenclature and tool angles. Okay, so six angles you have. So these six angles you have. So this part you should consider the type of chips. So continuous, discontinuous, you know, now tool nomenclature X, ORS, and tool angles. So six angles you have, like everything like inclination angle and all the clearance angles you have. Okay, so this part you must consider. In introduction, you have different processes, you know, and in that we are specifically working on cutting only. So due to that part, we are working for types of chip in that part. Okay, so this introduction to machining process, and from that machining process, we went to type of chips, tool nomenclature, and tool angles. Selection of tool angles. Okay, so for optimum cases, what tool angles you will select? The forces in machining. Okay, so how what amount of forces are actually acting in the machining? Okay, so you must consider the forces that are actually happening. Okay, so and the forces actually taking place, so how they're acting, which part they're acting, selection of two angles, so you know how to what angle to select, how to increase it, how to reduce it, so what are the effects of it if you increase it, what are the effects if you decrease it, so that part you must consider. Okay, so graph you must consider this for tool angles and tool geometry, tool geometry specifically. So tool angles is more important. So according to tool angle, how the things will change, how the forces will change. So that part you must consider. Okay, so this part you must have in your mind. And merchant circle. So there are many formulas. You know there are many formulations in that merchant circle diagram. So for formulations for calculations, you must know the merchant circle. Okay, diagram for complete calculation of forces. So there is definitely question of forces. Okay. So to calculate the forces, you need to go through complete merchant diagram, merchant cycle diagram. Okay. And okay, so after that you go with frictions in metal cutting. So amount of friction that is actually happening. So how the friction is happening and how to calculate it, why it is necessary. So that part you must consider here. Okay, so friction, that how the friction is actually taking place, how we can measure it, and what is the need of how we can, how it is actually useful in case of cutting operation. So that this part is actually explained in these conditions. Okay, the other machining operations like drilling, you know, drilling and milling and grinding. Okay, so this part, other option like grinding is there. Okay, so this grinding part you must consider here. These are the other machining operations that you should consider. Okay, so in every case the friction is there, friction in metal cutting. So the forces that are actually happening, the heating zones, okay, the heat affected zones, how we are using cooling, heat is taken by the chip, and how it is actually, how what the way your coolant is actually moving, how it is reducing the friction, and how friction is mattering in your cutting operation. Okay, so this heating zone, and this how actually the friction is considered, what friction you are considering in your theories. So how the friction is actually controlling your machining process. So how the metal is actually, this means actually friction in metal cutting process, actually how we are controlling, how it is affecting the process parameters, and how we are actually trying to complete control it. Okay, so this part like heating and lubrication part, other part will come into picture, and other machining processes, so drilling, milling, and grinding will come into the picture. So in this part also the friction will be there, but here we are actually focusing on cutting only. But it is only the part like it is actually applicable for most of the cases. So friction is everywhere in metal cutting. Okay, so and merchant circle also you should work with the calculations. Okay, the formulas is more important here. Okay, so your formulas are more important. So go work with the formulas properly, and you have to remember the formulas. Okay, so it's actually and mostly try to remember each and every formula. Okay, formula is very important. Okay, and as a theories part you can consider, but assumptions part, but formulas is more important. Okay, so in merchant circuit diagram you can consider other theories also. So how they are actually work, how they consider the part. So you can work on the theory part, but formulation is more important. Okay, so this are the part, other machine process is not drilling, milling, grinding. We go with, and the force measurement. So in all cases, there is a force is actually applied. So you are using dynamometer, strain gauges. Okay, so a strain gauge you are actually using. You are using dynamometers. Okay, you are using dynamometers and strain gauges here. So how we are actually measuring the forces, the shapes in like this octagon. Okay, so octagon like structures. Okay, so you know these octagon like structures what you actually have. Okay, so these kind of structures here we have there, ring like and octagonal type. Okay, so these type of structures you have here, ring type and octagonal type, and different, there will be some different like extended octagonal also there. Okay, so this kind of structure you have. So how it is actually happening. So at what angle it is there. So what angle it is still is happening. So here it is actually stabilizing it. So this part you must consider in force measurement. Okay, so how the force is getting measured by the strain gauges and dynamometers. Okay, and the tool wear and tool life. So tool, how the tool is getting wear and tool life. So tool wear means you know frank wear and those blank, and your creator wear, blank wear. Okay, creator and creator wear. Okay, so creator wear, frank wear, and tool life. You know the Taylor's tool life equation. Okay, Taylor's Taylor's. So the Taylor's tool life equation you must know. Okay, so tool life again you have to calculate the tool life. You know the numeric computation for that tool life. So and tool wear you mostly go with the theory part. Okay, so how it is happening, why it is happening, the theory part you must consider here, and the creator where plank where how it is happening, what is the mechanism, and tool life you are mostly have the formulation for using Taylor's tool life equation. Again, you can go with theory part also. Factors affecting the tool life. See, the theory part is here. Factors affecting the tool life. How to control tool life. Okay. How to control means basically how to increase the tool life is your actually concept. Okay. How to increase the tool life is actually your concept here, and how you can increase the control life and increase your production, or if you require some other properties, so you can how you can manage everything and optimize the tool life. Okay, mostly increase or optimize the tool life. That is your actual use here. Okay, by this theory part. So factor affecting the tool life. So again, so grinding is conventional, but mostly we are using abrasives to is higher added applications. But what process are actually using? Okay, so limitation of conventional, and it is actually used for super finishing. You know this part why it is using. So this is actually used for super finishing or finishing processes. Okay, so abrasive finishing processes where you are actually using this abrasive parts for machining. Okay, so it is actually for limitations of conventional machining also. We are using the non-traditional machining here also, and the abrasive also, that part also comes there. But the part that not come is grinding only. Okay, so grinding will not come here. Grinding is your conventional one, And again there are many other processes which actually called non-traditional processes. Okay, so again there are many processes that come into abrasive machining processes which are actually non-conventional. So we are actually using bonded abrasives to cut it. So it is actually used for finishing. So we are in abrasive machining, the material removal rate is low. Is low. Okay. So grinding you can consider, so overcome the limitations of this you should not consider here, but it can be considered because many you can show the abrasive jet is there, abrasive water jet is there, ultrasonic is there. Everywhere you're using abrasive. So it can be considered for limitations of non-conventional process. The conventional process we are introducing non-conventional processes. So, but in this specific part, we are only focusing on the grinding part. Okay, so here we're only focusing on grinding part. So grinding part is very important. Okay, so grinding part is here important. So abrasive machining processes means specifically grinding, super finishing, and metal removal. It is low. Okay, so we are actually using the bonded abrasives. Okay, for grinding process. We are using bonded abrasives for grinding process, and that abrasive is actually cutting the material. So what are the abrasive machining process like honing, grinding? Okay, so honing and there's something honing is there and think so lapping is there. So those processes abrasive machining. We are using low bonded abrasive, low material removal and abrasive we are using to cut materials. Okay, economics of machining. We see the grinding process is here. So I told you grinding process, like it is only abrasive process. So grinding process is abrasive machining process. So it is actually there. So grinding, you must consider everything about grinding. Okay, it's everything about milling. I told you like, other machining process means milling, grinding, and drilling, milling, and grinding. So everything you must consider for this process. Okay, so your MRR part I mentioned in previously. After that I mentioned these parts. So everything you should know about this process. Okay, in depth actually those part that actually teach in class you should know in depth for grinding, milling, and drilling and cutting of process. Okay, so this is again important part, and again the formulation part is part. Okay, and right after that we come if we come when we completed our actual machining we go for economics of grinding. Okay, so the cost R1, R2, R3. Okay, and R1, R2, R3, R4. Okay, so this part you know, and the other parts. Okay, so time you would need to time to have time and cost. Okay, so economics of machine time and cost, and again what criteria you should do the maximum production or minimum time. Okay, so and minimum profit. So this part you must consider. Economics you should consider depending upon that. You should consider your time cost. Okay, so that calculation, that formulation you must know. Okay, that is a very important part. That formulation you must know. And the non-traditional machining means here you can mention this part. Okay, so to improve, to get over the limitations of conventional machining processes, we actually need non-traditional machining processes. So you know this part. To get over limitations we actually introduce non-traditional machining processes. Okay, so these are non-traditional machining processes, so you must know everything about this part. Okay, non-traditional machining processes, this part you must know because there are basics, there are MRRs, the field properties that you have to calculate. So mostly the principle and the formulation. Okay, principle and formulation and basic idea. Okay, so about some description, brief description about it. Okay, the parameters, how the parameters are actually behave. So that part, the parameters part, brief description is the parameter part, how it behaves for specific conditions. Okay, that part you must consider here, non-traditional machining process. Okay, so again after that you will have the computer numerical control CNC machines. So okay, so in those CNC machines, what you have? So mostly how to control that part, how to control everything. Okay, so how to control our computer aided machines, how to create a mostly part program. Okay, so part programming thing you must work here. Okay, that part programming part you must know work here, and other parts. Okay, so like drives and loops and control. Okay, so this part come into, so basically computer numerical control is about how you can use the basics about your CNC and how you can use or you can operate the CNC machines. So that is what they are actually telling here. So how you can operate those CNC machines to get output from it. Okay, so your part program is important. Your drives, your loops, your control, your motors. Okay, so and control system is your feedback systems. Okay, so that feedback part. Okay, that is important here. Okay, so these cases are actually important here in your computer numerical control part. Okay, and what is the regional metrology? So in that you must consider the measuring instruments. Okay, so measuring instruments and your fit, your tolerance, allowance, discount calculations, okay, and the hole and shaft calculations. Okay, your discount calculations and hole and shaft calculations. Okay, so this part you must consider here. I mentioned it in the previous this after this part I mentioned everything. So okay, your drive, your loop. So this part is the metrology you are working on. So and this is actually for the CNC part. Okay, so the control is for the CNC part, and this is for the measuring instrument, fit, tolerance, allowance, and for the methodology part. So and laboratory demonstration, you go through laboratory part. Okay, so what you have in lab. So from tools to machining, okay, tool, machines, their arrangements, the product, the machining settings. Okay, so what things you should arrangement. Okay, so arrangement, machining settings, and live demonstration. Just must consider the tools that you have there. Okay, so what is the use of that tool? Use means accuracy, like this part. So how it actually looks and function. So that part machine. So in principle, how to use precautions, how to operate, is how to use operation and arrangements here. Okay, so arrangement means arrangement in machines. So how machine is getting arranged, arrangement in your machines. What the settings you should keep, arrangement for desired machining operation. So product. So what type of product you want. So means what kind of product you want, like material and where to mount. Okay, mount and how to select everything for product. So desired product you have and how you can manufacture it. Okay, desired product, how to manufacture. So that part. So this part and machining settings again for arrangement for specific kind of product unit, specific settings for machine. So how to operate that machine. Okay, principally use how to operate that machine, how to operate machine settings, and there's some live demonstration for other processes. Okay, other simple processes. like filing. So like filing, drilling you have. So this part you must consider. Okay, so like what processes that they are covered here: filing and drilling, they are actually covered. So again, so CNC part they covered, and cutting they have covered. For the sawing option, the cutting they have given you, drilling they give you drilling, and your threading, threading, reaming also they show you reaming, threading, and in CNC they show you gear cutting. Okay, gear cutting and dual gear cutting. Okay, so this part. Okay, so again gear cutting, and I think go to up. So dual gear cutting is also there. Okay, uh, can go here. Dual gear cutting. Okay, so dual gear cutting, and don't know actually what number is it. So after that actually they go with for CNC. After dual gear, CNC are also your shearing operation. Okay, or blank cutting mostly with the shearing operation to cut the plates. So shear you have shearing the shearing principle like guillotine mechanism you have there. Okay, so that guillotine mechanism you are shearing the part, and the CNC again. What two types of CNC? There is CNC lathe and CNC milling. Okay, you know this part. Okay, CNC again lathe and milling. Okay, so both CNC lathe and both CNC milling. So this both part we must consider. Okay, this actual processes they show. You can go through that laboratory demonstration part, so you can get the processes. It is for better your understanding, and they might ask you question also. Yeah, so you will get in that demonstration, you will get how the actual things are happening, how the arrangements are there. So you can get actual, you make an expectation from that part. Okay, it is actually for it is for theory and practice. So you can know the name of the course is theory and practice. So this laboratory may they ask. Okay, so you should go through this part quite accurately and work with this part. Okay, so this part is again important part. Okay, you must go this part as it is important part. Okay. So this is thing you should consider. And the important problems, two stress, which is mostly calculation part. Okay, so and two geometry related problems is the biggest part. Okay, so this is actually important. So and most important is this. Okay, so this is actually only have one formula, so it's not a problem. Two geometry related problems is actually quite critical. Okay, so you focus more in this part. Okay, you must focus more in this part. Okay, this is more important for you, and you must focus in this part. So material removal rate of the machining processes up to different machining processes. So two strain and two stress is just a single formula. So you must focus more here. This is just a single formula, and we must focus more here. Okay, here this part to geometry is actually critical part. Okay, so it's slightly critical. You must focus here. And material removal rate is just formulation part. Okay, this and this again this is also formulation, but you must consider that how it is working. Okay, so this is just formulation part. Okay, but we must consider, okay, so how it is actually handled. MRR is calculation part. You have to remember the formulas, and specific energy and power consumption again you must remember the formulas, how to get specific energy to power and how to get power from specific energy, that we must consider, and mostly units, most important units. Okay, so we vary. very critical with units. Units are the most dangerous. Okay, so very critical with units. Okay, so we must consider this part. Okay, and you see, how to convert it to power. It's in this measure with multiply with thickness. That is the only concept. So, and the convert into power consumption, specific energy, and MRR is again formula part. Okay. So time for machining, if you may you go for your economics part. So here a time for machining is important for everything. Means what mean by everything? Here for cutting, your drilling also, your milling, grinding. I don't think so, but much time for machining part, chip thickness in milling and grinding process. Okay, you must consider the T part. How to calculate the T thickness T1. That formulation part you must consider. Okay, that for is actually mostly it is a formulation part, yes, but that formulation part you must consider. Okay, so this formulation part you must consider, and just a formula. Okay, so machining time again to work on formulas, and chip thickness again work on formulas. Both are actually formulation problems. The strain measurement using different strain gauges. Okay, so you know how accurate is going to measure the forces. How you can measure the strain to get forces. Machining process to be very specific. How to get machining process by using strain measurement. Yeah, and again there are different type of strain gauges. So how we can use different type of strain gauges to get the machining forces. Okay, so that part we must consider here. Okay, and okay, so you know that ring type and afterburn type, and I previously show you that part and the formulas part. Okay, so a measurement of strain. So for strain E is equal to something. That part you must consider here. Okay, strain measurement using different strain gauges. So that E is equal to something. That part you must consider here. That is important to for calculations, and you will also get the formulas for that. Okay, so questions for that in your assignment. So that part is important here. So you must consider these parts for your preparation for exam. Okay, so you must remember those formula parts. Okay, here it's also work on the formulation part. Okay, so this part also work on formulation. And tool wear and tool life is this is theory part, and this is Taylor's post Taylor's tool life equation. Okay, for calculation part. Okay, so you must know this part for calculation. So yes, Taylor's tool life and tool wear. This tool wear is mostly theory can create a blank where and how factors are fitted to that and tool life for equations. Diameter of average, you know formula for that. Just one single formula. Okay, just single formula. Okay, and selection of variable. Selection of variable is most critical here. Okay? It is the again the most critical. Okay, like you know that A and that 10 number open or close. Again verified bond. Again it is open or close. This that complete set. Okay, so that 5 letters you must consider. Okay, this something X something. This is 5 letter you must consider. Okay, verified bond is the last. So this part you must consider. Okay, selection of branding wheel and a nomenclature. Okay? Selection and nomenclature. Selection and nomenclature of your branding wheel. Okay, and nomenclature. Also, branding wheel is important. The selection of branding wheel is the most critical part. Okay, so spend time on it. How you can choose like which bond you will choose, which material you will choose, which thickness you will choose. So which again which material and how open structure depending upon surface finish you want, bond and your gap. So those part is more critical here, and you can focus more on this part. Okay, for your exam preparation part. Okay, so this is again, so this part was critical part. So you work more for proper selection from required application. Okay, so again important problem. So number of chip produced in grinding process. It is simply the single formula part. Okay, it's just a single formula. And the surface requires calculation in different machining processes. Okay, so number of chip produced is single formula. Surface formulation for different machines. Surface roughness calculations. Okay, this is different with multiple formulas. This is critical again. Formulation and you must remember. Economics of machine. I told you with time and cost calculations. I told you in that at part also and here also you know everything. Time and cost. Time and cost for uh, different needs. Okay, so for different needs, how it is actually happening. So this time and cost must calculate depending upon the need and application requirement. Okay, so you work for the economics of machine process. So time and cost calculations. Operation parameters such as speed, depth of cut, speed, teeth, number of teeth per two different machining processes. So it's again. So this is most critical. Okay, I'm going to show you grade mark. So this formula you must okay. This is again critical part. Okay, so this formula you must consider. Okay, so this part you must consider the depth of cut, speed, number of teeth, feet per tooth, and in different machining process. So this critical part, how the feed is calculated. So mostly formulation, formulas to remember. So operational parameters using calculations such as this part. Okay, feed, depth of cut, speed, number of teeth, feet per tooth in the different machining processes. So it's like there are many others except it actually not these only. There are many others. So for this part, we must consider formulas for that. Okay, so it is a very critical part. Okay, so try to be more focused on this formulation part. So mostly this topic is mostly applied part. You might get this part. Okay, so questions must be applied, and they might ask you this kind of questions. So you must prepare for those formulations and must remember those formulas to get more marks. Okay, these parameters. Okay, the depth of cut speed, and they are also interconnected. You have to have proper formulas to use it correctly. Okay, so they may ask to calculate specific feed as they give different everything, and they may ask you to calculate this because most your maximum question will be of 2 months. So they mainly ask you these problems. Okay, so you must go through this part and remember the formulas. That is my simple suggestion to you. And the knowledge about the basic principles used in non-traditional machining processes and brief information about the processes. Okay, so knowledge you must have, basic principle you should work on, and brief information. So how the parameters change the output of process, that you must consider here. Okay, this is again critical part. Okay, this part is so you must know the about basic information and principles and brief information. The process again exactly as shown in case of at previous part. They may ask you to calculate the operational parameters. This is operation. I told you critical part. These operation parameters also you can calculate it. These process parameters in non-traditional processes also they may ask you voltage gap, speed. But non-traditional processes means current, voltage gap, speed, depth of cut. These parameters they may ask you. Okay, so time also time they might ask you. So you must go for the proper formulation for that. We consider all the formulas for that. Okay, mostly it is for formulas and okay. So this calculate must calculate this part. Okay, so his okay, so current voltage and there are formulas for that. You must remember that formula. That's only I can tell you. So this part you must consider current voltage, feedback, and depth of cut. This part you must consider and time and etc. This part that is taught in these classes. Okay, again, when you calculate these parameters, you also calculate the MRR. MRR is also important. MRR is the most important here. Okay, so if you can skip this part, but most important is the MRR part. Okay, and types of drives when you go for CNC. Right now you went for CNC part. So in that case, you will have types of drive, motors, control systems, adapt, and once you have drives, motors, control system, you have adaptive control. So like advanced. So types of drive controls, motors, drives, and control system, open loop, closed loop motors, step motor. You have different kind of motors and that drives that are used there. So motors that part. Hydraulic must hydraulic also be right. Pneumatic and hydraulic those parts may use or may not used. So though hydraulic and pneumatic, so and pneumatic actually, hydraulic, pneumatic and electrical I think so. Those parts and motors and petrol system like open loop, closed loop, adapt to their functions in adaptive control. Okay, so this part you must consider. Okay, and this is for things and the use of these functions. Okay, the functions, use of functions, adaptive control, how adaptive control working, types of drives, motors, and control system, open loop, closed loop. Okay, so that's it. CNC part programming. This is again the most critical, most important, and most critical. Okay, so you must most important and most critical, mostly remembering part. Okay, from some standard literature. Okay, so mostly people for standard literature you must know the each use of each block with X, Y, Z, and this part actually use how it is used, where it is used. Okay, so you must go through the standard literature and how the part program is made, how it is made, and use of each block, special blocks like M08 for coolant on, And the cycles. You must go through standard literature. So each how it is made, use of each block, use of special blocks and cycles. So these three things you must consider. Okay. So these three things you must consider. Okay. You must consider these three things here. These blocks, use of each block, special block, and cycles. This is most important, most critical. You go through these three things. These three important things. You must know these three important things. Okay. That's it. Say G71, G70 finishing cycle, G71 roughing cycle, and how to use them. Okay, how to use them means these codes, how to use these cycles, and how to use this both of them, the special blocks and blocks. Okay, so that you must know. Okay, so this part you must know. This three part and how to use them. Okay, how to use cycle and how to use your block. So this part you must know. This is the most important, most critical part. So you can have one mark star here also. Okay. And again important metrology is again important here. Metrology means how to measure your tools, scale, your equipment, principle behind that, measuring devices means mostly device, least count calculation, tolerances, unitary binary, A, B, like up, up, this X, this is up, down, the plus minus, allowance for your clearances, the fits you have, if you know the three fits like interference, clearance, and transient. Okay. So interference, clearance, and the middle it is transient. So this clearance and the condition for this clearance, this fits and the condition for this fits. These three fits and condition for this fits. This is important. Okay. What is the conditions for this fits and the uses of this fits? Okay, you must consider. Okay. Conditions for this fits and the uses for this and the uses. Okay, and so these three fits you must consider. Okay, there are conditions and condition you must remember and the uses. So it is actually uses part will be applied part. Okay. To apply uses, generally you uses to apply it. Okay, to apply. Okay, and the calculation for size of hole shaft depending upon the fit required in the problem. Okay, so calculation of shaft and hole size of hole and is again important. Okay. So calculation of size of hole and shaft is important for you depending upon the fit requirement like intermediate, like this clearance or interference, transient or clearance fit. Mostly we go for clearance fit, but who can be ask interference also. So may transient is between, so it's not that much important, but clearance and clear is important. Interference is important. Okay, so fit it is important. You know, I am important. Again, the conditions that are used for these fits and the uses of these fits to apply. and the calculation of a hole and shafts depending upon the fit and the required in the problem, maybe interference or maybe clearance. And again, after that demonstration part, so various tools used in the workshop floor, you must remember uses of these tools. What are the uses of this tool? So various tools you are used, and what are the uses of these tools? So that you must consider. Okay, so what are the uses of these tools that you must remember? Okay, mostly. So that part you must remember. Okay. Mostly you can get in some notes. So go with notes. Okay. You might get this part. Okay, so various tools and uses of these tools. A drive used for transmitting motion and different mechanisms. Mechanisms, different just this Geneva mechanism, and these are the actual mechanisms, different mechanisms, Geneva and guillotine, and transmitting motion means gears. So gears you use and the mechanisms you have. Gears and the mechanism like Geneva, guillotine, intermediate type. Okay, so that gears, how you are using these gears and uses and gear ratio, applications, various processes on different machines, and from that a lab demonstration part. Various processes on different machines, arrangement required, tool of workpiece selection, arrangement of desired product, knowledge about CNC machines, operation in CNC machines that I told you in that course outline part, course summary part. So this is again like less important, less IMP, like less IMP like something. But if you want to get to score 90%, you must know this part. Okay. As I told you, this is practice also, theory and practice. So you know this practice part. They might ask question on you, and I told you everything on our the course outline part just few minutes before. Okay, so there's just various processes or different machines that can be performed. Arrangements required, tool and workpiece selection, how to select, how to workpiece select, and arrangement for desired product. With machine arrangements and product arrangements, the different how to arrange everything. So this part mostly you should know is actually the single unit, not that much important for passing, but important for 90%. So if you want 90 percentile, go with this part also. Prepare this part well, so you will get more score. Okay, so arrangement and tool workpiece selection, arrangement for desired product. Okay, various process on different machines, how they perform, how they work on. So go for lab demonstration videos. Okay. About CNC again, about operations again, this is also for lab demonstration only. This is again applied here also. Okay. About CNC and also future use like lathe and milling. So lathe and milling part. Okay, so this is your lathe and milling part, milling CNC. What operations perform, knowledge about it, how the operations are performed, what operations are performed, how to perform those operations, you must consider. This is the last slide for this. So here we conclude the summarization for the course title ME91 Production Technology Theory and Practice. Prepare well, go through each part that I told you. All the best for exam. Thank you for your attention. Thank you, and all the best again. Prepare well, do your best. Thank you for listening, and all the best for your exam. Thank you.